esters are known to us. Now, give the heading esters. So let's start our work. This is the structural formula or the title shape of esters. Esters are alkyl alkanoates. At this point of syllabus, they want people to reconnect to IGCSE and they want people to remind themselves that how we used to construct the family of esters and how we used to name them. Esters are alkyl alkanoates. They are considered to be carboxylic derivatives. They are considered to be carboxylic derivatives. So esters are alkyl alkanoates, RCOOR prime. Okay, so you have to copy this. Have you done it? Yes. Shahid,
No,
have,
not yet.
okay. Now, let us make our next concept and what this as how the esters are in this chapter. Syllabus says that esters are considered to be derivative of carboxylic acid. So now let us put our next concept. Esters are considered esters are considered to be considered to be derivatives of carboxylic acid. Now, how they are carboxylic acid derivatives? What are carboxylic acids? Look at the look at the shape of carboxylic acid. What are carboxylic acids? They are RCO, RCOOH. Achha, it's important to remember that in a carboxylic acid, we have a double oxygen with hydrogen. Okay, this is carboxylic acid. Achha, syllabus believes that you can convert a carboxylic acid into an ester by removing the hydrogen, theoretically removing the hydrogen. Now look at this working. Look, this is how our syllabus believe that this is ester is a derivative of carboxylic acid. So I have replaced H. I have replaced H by R. This is how an ester is considered to be a carboxylic acid derivative. This is the functional group COO. COO is the functional group. COO is the functional group. Can you identify a polar bond here? Yes, Shahir, can you identify?
BO.
Hmm?
Wouldn't it be OH, the polar bond?
No. I mean bond polarity. Can you identify the bond polarity here? Carbon would
Is
be
plus and
positive,
the
oxygen
other two are minus.
would be negative. So you will identify there are two there are two polar bonds. Now, naming esters, how we develop the nomenclature. Esters have two parts. Look, this is how we name them. The first part, which contain carbon oxygen double bond, is the alkanoate group, and the alkyl radical, which is on the right side, which is alone, which is not connected with carbon, is the alkyl radical. This is how the esters structure is divided. To give the heading, naming esters, side heading.
Yeah, done.
So now we are putting this example that how we name it. One side becomes alkanoate and second side has to become alkyl. Now you have to copy this template to memorize. You have to copy this. I'm just coming in a minute. Please copy this. Now, this is the first example. Can you name this compound?
Methyl ethanoate? Or is it ethyl methanoate? Wait, I think methyl ethanoate.
So what's the name of this one? This one is ethanoate and the right one is methyl. It will be methyl ethanoate. Look at the name. Yes, Shahid, can you compare it with your answer?
Yeah, that's what I said, methyl ethanoate.
Okay. This is bonding. This is the ester bond. Look at the structure. This is the displayed formula of some of the esters which we can name. Left one is propyl ethanoate. Right one is ethyl propanoate, methyl ethanoate, and ethyl methanoate. Just observe them orally. They want us to recall, Shahid, the displayed formula. They want us to recall the displayed formula, the displayed formula, also the skeletal formula, also the structural formula. So these are the examples of displayed formulas. Now, structural formula. Structural formula, do you remember structural formulas? Yes, Shahir, can you hear me? Shahir, are you
Yeah,
there?
yeah, yeah, can you?
Look at this. This is a structural formula. So can you name it?
This is methyl ethanoate as well, no?
This is methyl. That's right. Very good. Methyl and there are 3 carbons on the left side. This is one segment. And this is the second segment. Acha, it is methyl. Then what should I write after that? How many carbons it has? Methyl.
Propanoid.
Yes. Now, skeletal formula. Skeletal formulas are like this. And you know them from your AS chemistry, that they are showing only the links and the other atoms other than carbon and hydrogen. So now you can copy this and you can name it. Yes, Shahir, have you copied it?
Yes.
Okay. Now, the first one is propyl formate, then ethyl acetate, methyl propionate, iso mean isomer, isopropyl formate. What are the formate and acetate? When there are two carbon, it's a conventional name acetate. When there is one carbon, it is methyl amine. For methyl, the formate is there. The older name was formate. So these are some of the skeletal formulas. Now, many ester, this was a famous discussion in our IG, that many esters are having a sweet smell. This is actually for which they are famous. This is why they are used in artificial flavors, and they have unique smells. Their food grade version is used in many artificial aroma. Hydrolysis reactions of esters. Our next heading. Acha, haan, copy this. Esters are, after that, please copy this famous concept, which is always there. Um, a very famous concept, which was in our IGCSE. Let us write again, which comes here also. Esters are sweet smelling. Esters are sweet smelling compounds. Esters are sweet smelling compounds. They are used in artificial flavors like apple flavors and other flavors. Now give the heading hydrolysis reactions of esters.
Yeah, copied.
Now, what is hydrolysis? Hydrolysis is the introduction of OH group. It's a reaction with water. Normally, the famous reaction we did discuss in our previous chapter, alcohol plus carboxylic acid gives you ester plus water. Now, if you reverse this equation, esters have a strong tendency to react with water. Ester plus water gives you alcohol plus carboxylic acid. Once again, remember that there are two types of hydrolysis. One is called acid hydrolysis and second is called alkaline hydrolysis. So we should recall that when you make ester, water is there and water and ester very happily combine. That is why we put any acid catalyst like H2SO4 so that water should be removed. Otherwise, it's very, very obvious that ester doesn't stay on the right side. Equilibrium comes back. Why equilibrium comes back? Because water has a strong tendency to react with acid. So what is hydrolysis? We discussed this concept before also. Hydrolysis is the reaction of a substance with water. We discussed it earlier and this concept is coming back. So let us discuss again that there are mainly three types of hydrolysis. Hydrolysis are of three types. Number one, acid hydrolysis. Number two, alkaline hydrolysis. Number three, by water. Three types of hydrolysis are there: by using an acid, by using an alkali, and by using water. Acid hydrolysis, ester plus water. Ester plus water gives you alcohol plus carboxylic acid. Remember this point, Shahid, that this is a reaction which is very spontaneous because, as I mentioned, esters have a strong tendency. Esters have a strong tendency to react with water. And that is why whenever this reaction occurs, this reaction can occur under room conditions and esters are always ready to go for it. Acid hydrolysis, look, there is an H plus on the reversible sign. Propyl, for example, propyl ethanoate plus water gives you propane 1-ol plus ethanoic acid. H plus shows the presence of acid. Remember, if you put H2SO4, it will retard this reaction because H2SO4 is a dehydrating agent. Achha, if you put HCl, it will favor this reaction. So if you want to do hydrolysis of ester, do not put H2SO4. Always try to put any other acid like HNO3, like HCl, etc. So now give the heading acid hydrolysis and copy this.
Yeah, copied.
Acha, acid hydrolysis and alkaline hydrolysis both require heat under reflux. Ethyl butyrate has a fruity odor similar to pineapple. This is another concept of smell. Now, remember this concept. They ask it in the paper. They call it conditions. Whenever you're doing hydrolysis, you need to heat under reflux. And reflux is something we have discussed number of times. Now, alkali hydrolysis. Look at this. Ester plus alkali gives you alcohol plus carboxylic acid salt. Look at this reaction. And now the product is not carboxylic acid. This is something I had explained earlier also, that actually carboxylic acid form. Actually, carboxylic acid, it does form, but what happens, it quickly converts into a salt. So you have to now copy this. So ester alkali hydrolysis, have you copied it?
Yeah, copy.
Now, there is no equilibrium in this method because this reaction goes perfectly to the right side, and actually it means that this is more beneficial from the production point of view. This method is more profitable because no byproducts are formed. Esters are used as solvents. This is a very famous solvent. Esters have used in perfumes, flavorings, etc. Now you have to give a new heading in the same chapter, acyl chlorides. Acyl chlorides, we have discussed them indirectly earlier also. Acyl chlorides are very important organic reagent like nitriles. Nitriles are also considered to be important organic reagents. What are reagents? Reagents are those substances which are helpful in making other substances. In simple terms, actually, they are used in making other compounds, they are used in making other substances. So acyl chlorides are important organic reagents. So it means that they are used in making other compounds. Look at the translation. RCOOH, carboxylic acid. Look, we have replaced chlorine here. So basically, this is called acyl chloride. We have replaced OH by chlorine. So you have to copy this. Carboxylic acid derivative logic. Yes, have you copied it?
No, just 1 second. Yeah, copy.
Now, this is RCOCl. Okay. This is called an acyl chloride. Carbon to chlorine bond is extremely polar. Carbon and chlorine bond is very much polar. So it is RCO and chlorine. Look at this. So it also contains two polar bonds. It also contains two polar bonds. Now, how we name it in our language, they are called alkanoyl. So now you have to copy this. So, sorry, there's a mistake. Oh, just letter A error. Please check the spelling. I have by mistake. This is the spelling. Alkanoyl chloride.
Yeah,
Now,
this is with chlorine.
let's.
Yeah. Okay.
Alkanoyl chloride is the technical name, so we can. Now, for example, I am taking H3C COCl. Now, this is called ethanoyl chloride. So copy this example also, a very famous example, ethanoyl chloride.
Yeah, copy.
Okay, so this is the word, and this is called acyl chloride. Now we talk about skeletal. This is the skeletal structure. RCOCl. This is the skeletal. Structural formulas are always like in CH3, CH2. So for example, CH3, COCl. So acetic acid, propanoic acid, these are the acids, and down is their corresponding acyl chlorides. Syllabus want that you have to connect an acyl chloride with a corresponding carboxylic acid. Now give the heading, side heading, physical properties. I mean, we are talking about acyl chloride, so we are talking about their physical properties. So now give the heading.
Yeah, copy.
Okay. Now, number one is appearance. Acyl chlorides like ethanol chloride is a colorless fuming liquid. They're generally liquids like that. Solubility in water. Acyl chlorides can't dissolve in water. The reason is that they are actually interested in reacting with water. They have a violent reaction with water, and after the reaction, the product dissolves. Boiling points, acyl chlorides have actually, they have the dipole-dipole interaction, and obviously van der Waals forces are always there. Due to this van der Waals forces and dipole-dipole interaction, they have a bit higher boiling point, not very high, a bit higher boiling point. Now, these are the physical properties. Then when we talk about their chemical reactions, the reactions of acyl chlorides are, we consider with water, we consider with alcohol, concentrated ammonia, and amines. So now give the heading chemical properties. Chemical properties of chemical properties of acyl chlorides. Look at the first one, the reactions of acyl chlorides with water, alcohols, concentrated ammonia, and amine. This is our syllabus for the chemical properties. So now copy this list.
Yeah, copy.
So these are the reaction. Number one is water. Acha, reaction with water means hydrolysis. So the first one is hydrolysis of acyl chlorides. This is our first title to discuss. So you have to copy this.
Yeah, copy.
Now, what is hydrolysis? Look, hydrolysis just discussed today, I think in the same class. What is hydrolysis? Hydrolysis is a reaction of a substance with water. In our organic, we say it is the introduction of OH group. So this is our memory, which comes again here in the same class. That what is hydrolysis? It's a reaction of a substance with water. Now look at this reaction. CH3COCl plus water gives you CH3 COOH plus HCl. This is a quick reaction, and in displayed version you can see that chlorine is leaving. Chlorine is chlorine carbon bond is polar. chlorine is always ready to leave the system. Chlorine has a weaker bond. The bond is polar. The OH coming from water attacks the chlorine, and chlorine is substituted by the OH group. So now you have to look up this.
Yeah, done.
Hmm.
Actually, well, this is SN what? SN
Huh. Do you
one?
remember SN? Huh, we are not here. We are not. This is not a concern that is it an SN1 or SN2 like we do in another chapter. But do you remember what is SN?
Yeah, it's the reaction mechanism.
Hmm. Now, general mechanism of nucleophilic substitution here. General mechanism of nucleophilic substitution. Acha, you were explaining me that how it is substitution.
The electrons go to O and then it attacks. Sorry, not O to Cl. And then the OH minus, the nucleophile attacks it, attacks the carbon.
And OH is attacking.
Carbon.
Yes. So now give the heading. General mechanism of nucleophilic substitution. The name of the mechanism is condensation. Addition elimination is the internal word that what the condensation word is doing here. I hope you remember IGCSE condensation polymerization. When you remove something like water, it is called condensation. So now you have to give this heading.
Yeah, copy.
This is word. Now look at this mechanism. First of all, remember this rule that a nucleophile is negative. It will attack the carbon with a positive charge and the bond will break. The CCl bond will break. In the first step, an intermediate will be formed, which is unstable because the nucleophile will get into this molecule by attacking the positive carbon. Now the structure has a negative charge on one atom. So this structure is fairly unstable. We will discuss this more in detail. We have reached till here. This chapter is about to finish. So we have general mechanism, nucleophilic substitution. So we will inshallah continue in our next class. Allah
Okay,
Hafiz.
Allah Hafiz.